I'm Brian Atkisson. I'm an infrastructure architect with Red Hat IT. IT at Red Hat supports pretty much all of our internal and external facing systems, everything from our customer portal, access.redhat.com, to the website, to a lot of the internal toolings we use for the systems, for hosting applications, build systems, and so on, including OpenShift clusters, OpenStack, data center management, and so on. So we really experience a broad array of infrastructure and tooling that Red Hat offers. And so this morning I'm going to talk to you about our journey through configuration management. And you'll have to excuse me. I think I'm allergic to Portland, so apologies. And maybe it's the hippie dirt water. I don't know. No offense to the hippies. So anyways, Red Hat has long been an adopter of configuration management. And really back to 1998 is when Red Hat IT first started adopting configuration management. The company was about 5 years old at this point, and it became clear around 1998, Red Hat did not have an internal IT department. It became clear that one was required because we had kernel engineers, kernel developers maintaining the website, right, and running the latest Alan Cox kernel, which would crash all the time. And so Red Hat invested in building an IT shop internally. And at that point, we used a lot of just basic RPMs that laid down config files for our systems. And that was kind of horrible. You couldn't, it didn't handle environments very well, so being able to have the stage database server, talk to the stage application server and so on. Around 2001, CF Engine, it was kind of the glory days, and it was fairly new to the scene. So Red Hat adopted CF Engine for configuration management, and this was our first major foray into configuration management. And that worked on and off. It wasn't too great, but it worked well enough until around 2007 when Puppet came on the scene. Puppet was 1 or 2 years old at that time, and Red Hat IT really worked a lot with Luke Keynes back in the day and rolled out Puppet, being one of Puppet's major customers at the time. And so very quickly, after deploying Puppet and moving the majority of our systems onto Puppet, we realized there was a major gap with Puppet around orchestration. And do you understand what I mean by orchestration? Yeah. All right. So basically, right, when you're doing a release, you want some automation to go turn off monitoring on the back-end nodes behind the load balancer, drain the connections from a node, take it down, apply some new RPMs or whatever, lay down some new configs for your application, add it back to the load balancer, make sure all is healthy, and then move on. So you really need that level of orchestration to do basic releases. And so we found that Puppet really lacked in this area. You could kind of do some things, but it was really kind of hacky. And so we rolled out Funk, working with Michael DeHaan. It was one of his first projects. And Funk solved for that use case of orchestration. It was a YAML-based syntax. It worked really well. And so using that in combination with Puppet solved most of our needs. And so it was more or less steady state for a few years until Ansible came on the scene in 2014. And Ansible, for those of you who don't know, kind of built upon Funk and used a lot of the syntax and the format that Funk offered, but added things like managing hosts over SSH and so on. So we started deploying Ansible internally in 2014, and in 2015, our internal adoption was going pretty strong, and then Red Hat announced that we would be acquiring Ansible. And so that really was exciting for us internally because now we could double down on this technology and start leveraging the full ecosystems, as well as having that collaborative relationship with the Ansible developers. In 2018, we added Ansible Tower to the environment to solve for some of the challenges that I'll get into shortly. And so this is kind of where we are today, where we have our entire applications, and we're building new data centers on purely Ansible without using Puppet at all. So That's hot. All right, so why did we migrate to Puppet from CF Engine? At the time, development tools or development teams were doing their own thing. They would develop an application, maintain those configs in CVS at the time or Subversion or whatever. And then the night before a release, they would throw everything over to ops, and ops would, some poor soul in operations would have to spend all night trying to encode that into a CF engine. But we didn't just use CF engine straight, we built a templating engine on top of it. And so being Red Hat, and especially Red Hat IT, we wanted to make things as complicated as possible. So we deployed this application called CFGen that rode on top of CF Engine, and it was really a Perl templating engine. And we came up with our own Perl DSL, right, a domain-specific language in which we could actually encode Perl language or Perl code directly in config files. As you can imagine, that grew into a giant ball of suck, and it was just a lot of pain. So that's why we were looking to Puppet, not just to solve the technical challenges, but also solve the people challenges of getting both development teams and operations to work together better. And so the ideal of our Puppet implementation was that our Puppet modules, and Puppet modules are just a way to bundle up some Puppet code so that by application or by functional group, where these modules could be developed alongside the application, and then the development teams would own their Puppet module for their code, and all we would have to do when they go to production was promote the code. Everything was stored in Git. We used branches in Git for environments. Worked pretty well. We also had the infrastructure teams managing the infrastructure modules, which makes sense, right? Your base OS configuration, your IAM, identity and access management configs, your monitoring, and so on. And we had at the time, we had a release engineering group that kind of handled the in-between, so the middleware, JBoss, Java, Ruby on Rails, the whole thing. And everything just magically worked, and there was peace in our time. Not so much, right? A decade later, we found that we were encountering a significant amount of problems where it was hard to balance old and new operating systems. This was mostly due to changes in Ruby, and the Ruby libraries kind of, use a common build of Puppet across RHEL 3, RHEL 4, RHEL 5, RHEL 6, RHEL 7, now RHEL 8, right? It's just approaching impossible. The language itself is relatively hard to learn, and please, no one take offense by this, but it is. The manifest and the ERB templates are very much based on Ruby and come from that world. And so if you're not a Ruby developer, it's just hard to use. And dependency ordering was a nightmare in our environment. We had a very, very large code base, around 500,000 lines of just manifest code, multiple millions of lines of just configuration files and ERB templates, and it was just trying to get two Puppet runs, back-to-back Puppet runs, to work the same way time after time was enormously difficult because the way Ruby compiles it runs, and it handles dependency ordering different in every single Puppet run. So you have to be very careful to explicitly define your dependencies, which is hard when you're talking about dependencies across modules and across a very large code base. So what the net effect is, depending on how the dependencies were calculated in a Puppet run, you might have that Puppet run succeed or fail without changing anything on the backend code. We also found Puppet was extremely slow, and we had a lot of scaling challenges. We managed too many objects. It was a constant game of trying to fix the bottleneck, introduce more Puppet masters, scaling the Puppet DB. We also had a lot of problems with trying to manage the same data across multiple data centers. With Puppet, we had a pretty big reliance on store configs. And store configs is that mechanism in Puppet that allows one node to publish information about itself to another node. So think like a Nagios check, where you have to load something on the Nagios server, and that's how it's handled, but that's tied to a single Puppet database. And so trying to scale that Puppet database across data centers that are multiple thousands of miles apart becomes a real challenge. So our implementation of Puppet was even harder to learn. As you might remember, our deployment started in 2007, and so that predated a lot of the tooling that's developed in Puppet since. Stuff like R10K and Puppet Enterprise even, HIRA. So we had to solve all these challenges ourselves and do our own special thing. But then trying to back that out and switch to the standard tooling became enormously difficult and a major change that basically nobody wanted to tolerate. So the environment itself was hard to learn. Updates, as I mentioned, were approaching impossible. We found that app developers really disliked Puppet, maybe unfairly at times, just because of our environment. It was slow, there was a lot of overhead, and a lot of pain in getting applications to productions. As I mentioned, we just managed too many defaults, including operating system defaults. We were trying to use it as an audit system to make sure something didn't change. So in that rare case where someone would come along and manually SSH into a box and make a change, well, Puppet would revert it. That never really happened or happened very rarely, but still we paid an enormous performance penalty because we managed everything. At least we tried to. And as I mentioned, Puppet is and was extremely weak at orchestration. I know Puppet's worked a lot in this area and has a new tool for that, but at the time, and it still is, Puppet itself is kind of weak in orchestration land. So we started adopting a hybrid approach. And here in this scenario, we had Puppet runs being kicked off by Ansible. And so we'd use Ansible to manage a release, and then so we would schedule downtime across a cluster, down a node, disable Puppet across all the backend servers, right? Down a node, have Ansible go through and enable Puppet host by host to get the new configs and put it back in the load balancer. And this kind of worked. It was hokey, but it worked. With Ansible, we also found that dependency ordering became way easier. You just write the playbooks in order. I know it's kind of a novel concept, but it helps a lot, and it solves a lot of those challenges. The language itself, Ansible, is very easy to learn and understand. I mean, most people could pick it up after a few hours of looking at it. And there's enough resources out there to just copy and paste your way through. It's also agentless, which was really powerful for us. A lot of my background's in identity and access management. So being able to utilize the host access model was very powerful, and not having to bolt on something like trying to manage file level permissions in Git. The playbooks just utilize if you have SSH access to a server, you can run a playbook there. So being able to reuse what we already invested in for access management was very powerful. So then the next thing we did was deploy Tower. And shortly after Red Hat acquired Ansible, we open sourced Tower. And Tower is kind of the management system for Ansible. The upstream project's called AWX. It's free, it works well, it's fairly stable, but the community is also, that's where they innovate. It's pretty much the Fedora to the Rail, right? It's that upstream project. And Tower gives you, and AWX gives you centralized playbook execution, so a single node or a single cluster from which to execute all your playbooks. And that helps with, especially around RBAC, right, where you may not want your developers having root passwords or having direct access to SSH into a server. Tower handles that RBAC for you so that you could just give a developer access to run a playbook, to go, I don't know, restart Java or whatever, restart JBoss. And you don't need to give them access to the system itself. It gives you this remote playbook execution facility where it's just an API endpoint that you could go hit, and that will execute a playbook you already have, which makes it really powerful to construct a lot of more advanced workflows. One of the first things we did with this was create some auto-healing systems, wherein we had a Nagios check. check the service is running. If that service stopped running, Apache or whatever, we would have a Nagios event handler kick in, an NRPE handler, and kick off, and then that event handler would go hit the tower endpoint for that playbook, which would then try to remediate the whatever's broken, restart the service, or clear cache, or whatever needs to happen. And then it would self-recover. If it self-recovers, fine. We report an event. We throw a ticket into the application development team to go fix. But nobody has to be woken up in the middle of the night. If the system can't be auto-recovered, then it would page out to operations on call. And this worked really well. It also utilized some of Tower's metric systems. Tower has a pretty powerful metric collection system where you could see how long playbooks take to execute and use that to optimize playbooks and other automation. So then we moved on to kind of full adoption of Ansible. And so this involved using Ansible to manage our AWS and OpenStack infrastructure. So this is top to bottom, everything in the host VMs, provisioning, day-to-day management, termination when that instance would go away. Also includes long-lived and ephemeral VMs, and really kind of using Ansible's configuration management system, being able to manage templates directly and manage files, in addition to orchestration. We also backported it to the traditional data center to handle activities like provisioning. As I mentioned, we had a huge Puppet code base that handled laying down an operating system exactly how we wanted it laid down. So rather than have to backport all this to Ansible, we just had Ansible kick off a Puppet run on a template image, clone the image, and use that to provision VMs from that point forward, and then use Ansible for kind of day-to-day management from then on out. As I mentioned, also using Ansible for orchestration and releases. That's kind of where it really shines. When we started deploying OpenShift, and we have a variety of OpenShift clusters internally, and we're using it to run production workloads, quite a significant amount of workloads these days. So be able to use Ansible for that environment, for both managing the platform itself as well as applications living on it, with the same tooling is enormously useful. And then finally, we also started using Ansible in our CI/CD environments, where we would have Jenkins go kick off Ansible playbooks to go run. And these playbooks can run from Tower, or they can run directly from the Jenkins server. This saves people like me from having to learn too much about Groovy, which honestly I really dislike. And so it kind of gives a lot of flexibility to our development teams to be able to very easily manage their CI/CD environments in a standard way. One of the other benefits we found with Ansible was that it encouraged federated management of the VMs. And we've been kind of moving in this direction for a while now, where the app teams would run their own VMs and now containers top to bottom. Infrastructure teams don't run individual VMs, right? If they want to create a contract to do operational support for those VMs, fine. But still, the app teams own that VM itself. And so Ansible really lets us fully adopt this model where the app teams can utilize suggested Ansible roles that the infrastructure teams publish to create the VM. For those of you who don't know, Ansible role is similar to a Puppet module. It's just a way of bundling up similar Ansible code in a reusable form. Usually you would have one or more Ansible roles per application. And so the infrastructure teams provided this easy path, right? If you use these roles, include them, you could get to production very quickly. You could utilize Tower integration to run your playbooks. But we also have, being Red Hat, we want it to be open and allow people to innovate and support that. So if teams want to bring their own configuration management system, hey, they're welcome to do it, but they just need to obey some of the standard mandatory configurations. And then we're using OpenSCAP on the back end to audit to make sure that these VMs still comply with our security policies. So this works pretty well. Of course, we have to invest pretty heavily in OpenSCAP to get that level of compliance checking. We're also, Ansible has the centralized role distribution system, which is Galaxy. And I put Galaxy in quotes there because we're both using upstream Galaxy that's public for some roles, but we also have an internal Galaxy instance, which is more or less just a GitLab server, which we publish kind of Red Hat specific or environment specific roles. And doing this kind of encourages app teams to participate in creating these roles and helping us maintain them going forward. So on day-to-day playbook management, we try to stick with this idea that our roles should contain the smallest functional component. In something like Apache, you might have 10 different roles bundling different aspects of Apache configuration, but we wanted these to be as small as possible. And this encourages reuse. It also makes it easy for the dev teams to consume it without having to change individual roles and then having to coordinate that across the entire IT department or company in some big monolithic change that breaks everybody else's app. So keeping these roles very small is enormously powerful. All of our apps have at least 2 roles. So you would have your main functionality, so your main application, Apache, probably, like I said, 10 different roles. And this could be public. This could be directly from Galaxy. There's some great roles on Galaxy for doing standard things. Or there's also the Linux system roles that Red Hat publishes as a product to config stuff like postfix or NTP. So being able to leverage that and save on the development time of those roles is useful. But then we also have a wrapper role. And that wrapper role basically adds any Red Hat environment-specific changes, data, whatever it needs to do to invoke that role in a way that works in our environment. And these wrapper roles are not public, but they're more kind of internally specific data. Sorry, this slide's a little busy, but the approach we're taking is as we transition from the Puppet world to the Ansible world, we're doing that along RHEL releases. So in our environment, if app teams really want to run RHEL 6, they have to manage it with Puppet. They could also manage RHEL 7 with Puppet if they want. Or they could use Ansible to manage configuration files in RHEL 7 and now RHEL 8. We're not going to support Puppet at all in our RHEL 8 deployments. We don't, simply because we have an older version of Puppet, and it would just take an enormous amount of work to go through and to go through and try to upgrade that huge code base to Puppet 5 or 6. So we're just kind of drawing the line and saying no. For anything RHEL 8, you need to use Ansible for both orchestration and configuration management. Yeah, and then the message we're giving our app teams is just upgrade your stuff, right? Your app was probably going to work fine on RHEL 8 if it worked on RHEL 6. Just take the time, update it. Most of the folks in Red Hat IT run Fedora, RHEL, or Mac. And we do have some folks doing ad hoc playbooks, kind of one-off things to go, I don't know, change a piece of data across a cluster or something like that. And that works fine as long as they have access to the host themselves. They could do it from the laptop. Obviously, if you're a Mac user, just be aware of Apple's really old unfrozen caveman Python version that might cause you some problems. Anybody? Unfrozen caveman lawyer? Anybody? All right. The rest of you have no idea what I'm talking about. And so we've, over the years, we've learned a variety of experiences and lessons from this basically 2 decades of doing configuration management. I know I don't need to preach this point to this audience, but use the best tool for the job. It's not always Ansible. Don't try to make Ansible solve every problem. Sometimes it's easier just to write a script, right? It's faster. You have less to worry about. But also, don't be afraid to write your own Ansible module. If Ansible doesn't natively support an appliance or whatever you need, don't be afraid to try something and contribute upstream. They really like it. They'll work with you to get it in a form that it could be included in Ansible. One of the early mistakes we made with Puppet was trying to manage all of our data elements inside Puppet as well. So it later became HIRA, where we'd stuff every single thing, a piece of data, user access, database servers, web servers, LDAP servers, everything, we would define it in HIRA inside Puppet. And then that data would be locked inside Puppet, so it'd take a get change to go fail over a system from one LDAP server to another. Don't do that, right? Use service auto discovery. DNS SRV records work great. Use them. We finally found a use for Istio, which everybody talks about, to do kind of that service auto discovery. Right? You keep your user permission model, user permissions and authorizations inside a tool that's designed for that, whether it's free IPA, LDAP, Active Directory, whatever. Secret management is still kind of a pain point for us within Ansible. So we're looking at some solutions for this. Vault will only kind of take you so far. It works for kind of medium-sized environments, but once you start scaling up from there, it starts to break down and becomes hard to manage. So we're kind of taking a look at some other secret management systems. HashiCorp Vault is one of them, and so on. So for lessons learned, right, only manage what you need to manage. I know that kind of seems obvious, but don't try to use your configuration management system as an auditing system. There's other tools for that. If you need to know when a file changed at what time, use AID, use Stripwire, something like that. Don't try to overload your configuration management system. You're just going to pay an enormous price for it in terms of these runtimes for your playbooks or your Puppet run, whatever. It's just going to drag on, and you'll end up with 5-10-minute Puppet runs or Ansible playbook executions. As I mentioned, use authoritative data sources where you can. Get that data out of configuration management. And finally, don't be clever. Like, we all know how smart you are. You don't need to show us and create unreadable playbooks or indecipherable Python scripts or Perl scripts, even worse, right? Just keep it simple. Keep it readable. Also, as I mentioned, we try to start fixing people problems with our Puppet deployment. That doesn't really work, right? Tools don't fix people problems. You need to get to the source of the problem. In our case, we had a very large environment, but nobody was really looking after the health of our Puppet deployment overall and working with those service owners on best practices for playbooks and things of that nature. So we stood up a configuration management standards body inside Red Hat, and this is kind of a federated team with representatives from all over IT. And the idea here is to work with service owners to define those best practices, to answer questions, to create that consumable code and encourage reuse where we can, so we don't have 20 different people writing a JBoss module that, and everybody doing their own thing. Try to stop the crazy and idiotic things people do on a day-to-day basis. I know it's always a challenge, but it's a good step in the right direction. And finally, try to keep our Ansible environment up to date. We don't want to let it atrophy like we did Puppet, to be honest. So we want to keep it relatively current with whatever the supported release of Ansible is, and Tower as well. As I mentioned, unmanaged things are not managed, right? Don't make manual changes on the systems. Do not SSH into the servers to make changes. Just don't. Everything should be in config management. If it's 3 a.m. and you need to fix something, make sure you go back and you add those changes to config management. Or better yet, when you get in the morning, add it and blow away your VMs and start build them from scratch. You should have everything defined in code at that point anyways. Use Tower, use AWX. If you're a RHEL customer, or even if you're not, Tower is very useful. It's supported. It's really powerful. Or use AWX if you want something more upstream that's free. But use one of them nonetheless. This gives you centralized and audible playbook execution. So you really know who changed what and when and how they did it. It handles credential management for you. It also lets you do playbook chaining, which is kind of interesting in where you don't have to necessarily encode playbook ordering into your playbooks themselves. You could just use Tower to construct these elaborate workflows where if one playbook works, fine, go kick off another. And if that playbook didn't work, try something else. So that's kind of my new favorite feature of it. It's more useful than you would think it was. It also lets you use scheduled jobs. So we've been able to replace a lot of those cron job Perl scripts through the environment by just executing a job. It has a fairly robust notification system as well. So when something breaks, you get an alert, or if a playbook fires, you get an alert. As I mentioned, our auto healing systems. This is how we create tickets for the app teams or go page somebody else through the notification system. And so our next steps with a deployment, we're taking a hard look at what it means to be a data center in today's world. And so we're actually building a complete data center from scratch in a greenfield environment, using everything that's going to be based on OpenStack and Rev and Ceph with OpenShift layered across. And we're using Ansible to manage everything top to bottom. And there'll be no Puppet in this environment. It'll all be kind of hybrid cloud. And we've invested in a data center with very low latency to cloud environment. So this helps us be able to scale up to the cloud, to the public cloud, using OpenShift. So using this environment, we're really constructing this native system managed by Ansible top to bottom. And with that, let's say thank you. I'll take your questions now.
Thank you. Thank you, Brian. Sure. So it's time for questions. If anyone has any questions, just please step forward to the mic.
Hi there. Thank you. I was curious what other secrets management tooling you were looking at besides Vault. We're currently in kind of a similar state of looking to convert from Puppet to Ansible, trying it out in our environment, and also bringing in the secrets management we were previously doing in Foreman into some other tooling. Vault's been okay, but there are some rough edges there. So what else are you evaluating, and what are the pain points you experience with Vault?
Yeah, so we're looking. The kind of pain points with Ansible Vault is that data is locked inside the Ansible Vault, and applications can't get to it directly without having to go through Ansible. So we're looking at several tools. Barbican in OpenStack is one of them. We deploy Red Hat certificate system internally, so there's a KRA component, as well as a free IPA has a Vault system as well. We're looking at that. Of course, HashiCorp's Vault. We're looking at both the free version of that as well as the paid enterprise version. Those are the main ones. AWS has their own, which we're kind of taking a cursory look at as well. But really, we want something that's being able to be backed by HSM, so we can do key wrapping and all that. But also expose the secrets via APIs so that applications running inside OpenShift can go get a secret if they need it as well.
Thank you.
Yeah.
It was a great speech. Thank you.
Oh, thank you.
I heard two things that seem to contradict. It's only manage what you need to manage and make no manual changes. So how do you minimize what you need to manage when you don't make any manual changes?
Well, if you need to make a manual change, then you need to manage that thing and add it to configuration management. You know, one of the tricks with Ansible is you need to have Tower or something that can execute your playbooks, you know, throughout the day multiple times. Otherwise, they'll just atrophy and break. So you should be making regularly scheduled playbook executions on that system. So if you need it to manage something, throw it in there. Even if you need to go change it on the host directly, you know, add it in configuration management and make sure nothing changes the next time that playbook runs. But I really, you know, caution you away from trying to make those manual changes. I know in you know, some smaller single node environments, it's the fastest way to get things recovered. But at the same time, you're setting yourself up for pain later on.
Right. So if I'm hearing you correctly, don't over manage things that you'll
Right.
probably never change.
Yes.
Okay. Thank you.
Mm-hmm. Great. Well, thank you so much for your time.
Thank you, Brad.